let's look at the red blood cells. Here's a red blood cell. You got one here, right here. It's a round biconcave. What? It's a disc. You can play frisbee with. But it's shaped inside on both sides, not just on one side. So it's biconcave, they call it. Yeah, it's very good because you know what happens is these cells are made in the bone marrow, and you know how fast they make these cells. Well, that's in the other slide. It's about 160 million every minute. So that's half of American people in blood cells every minute that your body makes. 2 minutes, we got the whole population. That's pretty fast. It's all in the bone marrow. So they make these stem cells in the bone marrow, make these cells, and then they take the nucleus out and suck it out, and that makes this shape. There is no nucleus. This is pretty much a bag of hemoglobin. And hemoglobin has iron in it, and that makes it look red. But hemoglobin basically carries the oxygen around. What's interesting with this, look here, I wrote it down. This is a really good surface to volume ratio or system for what it is designed to do. Because wherever you are inside this vessel, there's not much distance to the surface of the cell. And so that allows, where is it? That's a short diffusion distance that facilitates oxygen uptake and release. And favors this. It's a very passive process, so it favors this passive process. It also favors when blood vessels need to squeeze through blood vessel walls that are very small. Were you wondering how that works? Ever? I was. So I had to find it out. When our tissues need oxygen, one of the things that we do, our body's going to make more red blood cells, and that's a process that's initiated by the kidneys. It's a renal means kidney, if that wasn't clear. Sorry about that. It's a hormone that's secreted by the kidneys, and the hormone's name is erythropoietin. I know. More and more complications. Erythropoietin is the hormone. What's interesting, if you think that through, what is dialysis? You got to filter the blood because the kidneys can't do the job anymore, right? So dialysis does give people erythropoietin deficiency, and they often get a decreased red blood cell count, which we call anemia. Anemia can either be a red blood cell count that's low, or just an oxygen count that's low. So it's really an oxygen count, but most of the time that indicates a red blood cell count as well. An increased number of cells, generally speaking, but we can use it for red blood cells also, is called a polycythemia. Poly means many. And cythemia is cells, many cells. So too many cells is polycythemia. Here, the next one, look at that. Those blood cells, they are made in vast quantities, but they don't live as long. They live a third of a year, more or less. And then they go bye-bye. And so when they start going bye-bye, they go to the spleen sometimes to the liver. They get a little, their walls get a little fragile, and they get caught. And they die. Let's talk about white blood cells. So in red blood cells, and this is a smear that you will work on, there's many. So we said a cubic millimeter. Millimeter by millimeter by millimeter, that's a microliter. Has 4.5 to 5.5 million. Yeah, that's just a relationship problem. I can't compute that. It's way too crazy. On the other hand, white blood cells are about 4 to 8,000 per cubic millimeter, so I can get that a little bit better. So that's, we have, that's not as hard to conceive. We have 5 groups or flavors of white blood cells, and they do different things. So we want to talk to them a little bit of what they're doing. Some of them are termed granulocytes, and some are agranulocytes. And that just has to do with how do they look under the microscope when they stain them. In order to see a lot of these things under the microscope, you've got to put a stain on them. It makes things look differently so we can see what we're looking at. And we have like 3 of them, and they have little granules looking things in there, cytoplasm. See that? So they call those granulocytes. And then we have 2 that don't have granules in, or not like severe like that, and they call them agranulocytes. A meaning a lack of granules. And we have subgroups on the granulocyte. We have neutrophils, eosinophils, basophils. Move on. And then on the adrenolymphocytes, oh, look at that, I have an extra space in there. We have lymphocytes and monocytes. Whoop. Got it? Let's go through them. A few more things before. A lifespan of one of these things just depends on who they are. Those can live a lifetime. Some of those, actually these ones, are the ones that hold the information for every pathogen that can enter your body. And if it does, it's learning what it means, and as soon as the next one comes in, it goes and shoots it down. That's the T cell. Awesome. I don't even know the monocyte yet, but that's also important. So that was a lymphocyte, but we'll go through that. So those live a lifetime. Some of them only live a few hours, and then they eat themselves. They eat foreign stuff up, and then you get pus. Have you ever had pus? Yeah, that's part of these cells. There's other stuff in it. Is pus. They destroy themselves. They are so selfish. You know, next time you feel bad about yourself or the life or the world, you just realize you have so many of your own cells that kill themselves for you. Just for you! It's so nice.
What's that called?
Neutrophil. These cells make up the structural portion, or a large structural portion of our immune system, together with lymphoid organs, which are the lymph nodes, and the spleen, and the thymus. Then we have an increased amount of white blood cells. We have over about 10,000. Some books call it 11,500 or so per microliter. That is called leukocytosis. Here we go, leukocytosis. That usually means it's an infection. So you get sick, you have the flu, that's what you have, leukocytosis. You get swollen lymph nodes, it's a good sign. That means your body works. If you're sick and you have no swollen lymph nodes, that's to be worried about more. Because your body doesn't work. Your body's job is to keep you in homeostasis. That means you need to be as similar inside as possible, even though the outside's always changing. So if you get a pathogen coming in, you might have to get a little fever so the body can get rid of that to be back in normal. So a fever is a good thing. Most white blood cells, they move around in the bloodstream, they stay there for a while, and then they actually move and leave the blood system. They use the cardiovascular system as a means of transport to get from A to B where they need to go. Because if your tissue is injured and has some problem, there's chemicals that come from that tissue and they tell the white blood cells where to go. It's like radio waves. See, we think we're so smart. Our body's way smarter. So they send like radiochemical signals to us that the white blood cells know where to go. They go to the side of the injury. They call that chemotaxis. Have you ever taken a taxi? The taxi? It's a taxi with chemicals. Chemotaxis. And then when these white blood cells, they can just move. First thing they have to do is they have to squeeze out of the blood, squeezing through that thing, that little slit. That's called diapedesis. Now that's a cool word. PED. See the words right here. Diapedesis. The PED part refers to your foot.
Right.
You're a pedestrian when you walk, right? That's the same word. Dia means through something. So diapedesis means they walk through the cell wall. So they walk through the blood vessel wall into the tissue and then move with amoeboid motion. That means just they move by themselves to the area where they need to go. The area where they are attracted to via the chemotaxis. Those neutrophils, they phagocytose. That means phagocyte. Phage means eating, remember? So phagocytosis means eating. Remember, pinocytosis is like Pinot Noir, means drinking. Cellular drinking. So they do that, they eat up foreign stuff that they find. Most of the time that's pathogens. Things that make us sick. They destroy them by releasing those enzymes, those lysosomal enzymes in them, but then what happens, they often perish themselves. They kill themselves. And then that's the pus that we get. So those cells are the one that, if we have a place of injury, they go there first. They show up, they go there, they eat up what they need to eat up so the infection doesn't spread, they dissolve themselves and kill themselves, and then other ones can come fix them. So they're pretty cool. They're really very selfless. And they're most numerous.